Good afternoon, everybody, and welcome to our presentation today, entitled A VR Touch Studio for Sight-Impaired Users. Myself and my colleague, Dr. Alice Barrow from Generic Robotics, are going to walk you through our presentation about a recent study, and we're going to offer you the science behind touch. I hope you've all got your notebooks at the ready. You may need them. I'm going to just pass over to my colleague now, and we can carry on with the presentation.
Brill. Thank you very much, Lisa. So hello, everyone. I am Ali from Generic Robotics, and we're working with Open University on what is a pretty exciting project. So I think my task or remit is to cover haptics and haptic technology in the sense of touch really briefly as an intro. And then I'll hand back to Lisa to really dive into the project itself. So if you want to whiz on to the next slide. I don't know if you want to very quickly give an overview of what's coming up, Lisa.
Yeah, sure. So the contents of this presentation have been aligned to the double diamond D, which we've been using not only for our project, but that designers use every day as part of their process. We've started with the Discover. So as Ali said, he's going to talk about Haptic 101. He's also going to very excitingly talk about Toya, and I'm going to then sidestep into inclusive design, universal design. I'll present the deep dive study that we've conducted with our participant users, and I'm going to talk briefly about assistive technology and what that means to our users. We're then going to come on to people. People are at the core centre of this project. I think by the end of this presentation, you'll come to understand and learn that. Our demographics and the background details of the users, and the part of the process that we value the most is the user's input, and we very much think of them as co-designers. We're going to then show you our developments within the project and a little bit of film footage around testing. And then we're just going to discuss and present and hopefully get to the next level offering, which is also very exciting. And we're going to ask questions of you as we go along for you to think about and consider as part of the presentation.
Okay, right. So haptics, or more specifically, the sense of touch. So there isn't anyone watching this, whether it's live or whether it's a recording, who isn't benefiting from their sense of touch right now. So it could be because you're typing and not looking, or just holding a pen, or it could just be because you're not falling off your chair and your bum is detecting the forces being applied to you, and you're correcting your posture without even thinking about it. So our sense of touch is completely pervasive. It's always on, it's always present. And so that nice hot shower in the morning, as in the picture, if you didn't have the sense of touch, it certainly wouldn't be a nice hot shower. If you closed your eyes, you wouldn't even know you were getting wet, basically. So the sense of touch is just everywhere, effectively. And it's incredibly important to everything we do. Do you want to flip to the next slide, Lisa? So the sense of touch is the first sense to develop in the womb, and in many cases it's also the last sense to leave us. Next slide. And it's unfathomably complicated as well. So in this fairly simple example, if I run my fingers across a flat surface like a desk, then there's receptors in my fingertips which are responding to the vibrations, and those vibrations are turned into electrical impulses, and my brain interprets those into qualitative experiences like roughness. But it doesn't matter how fast I move my fingers backwards and forwards across the surface, even though that changes the frequency and the intensity of those electrical impulses, my brain still experiences consistent roughness. And that's all part of the fact that the haptic sense, this sort of sense of touch, is the only sense which is bidirectional in nature. So when we see, we receive visual information. When we hear, we receive auditory information. But when we touch, it's an interactive process. It's a two-way process. And in psychology literature, that's referred to as active touch. You close the loop, you make a purposeful action, and you receive information as a result of that action. And then your brain interprets and understands that. And it's pretty amazing. And it goes much deeper as well. So I don't know if you want to flip onto the next slide. So I mean, loads of amazing experiments exploring sense of touch. Some of them are a little bit hard to replicate, but there's lots and lots of studies showing things like if you hold something warm, you're more likely to be more generous or make more generous decisions. If you hold onto something rigid, you're more likely to be resistant to external influence. So the next time a salesperson gives you a warm cup of tea and sits you somewhere comfy, you just want to be on extra high levels of guard, just in case you're about to be sold something you weren't expecting. So next slide, please. And yeah, it goes even deeper than that. It's really easy to think of the sense of touch as a mechanical process, sort of a physical process, sculpting, picking things up, that kind of thing. But there are specific nerve fibers that transmit emotion through the sense of touch, afferent nerve fibers. And I mean, we kind of know that intuitively, because sort of some of the most heartfelt connection we can make with another person can come through sharing contact, not through words. And so there is lots of ways to sort of prove that and explore that. And there's even, if you want to go to the next slide, there's even a whole series of experiments exploring just that. So in a slightly creepy example, two people standing either side of a curtain, one person reaches through and attempts to convey emotion. They can do that incredibly well. Just with that simple act of reaching out and touching someone through a curtain, you can convey all sorts of emotions like anger, disgust, fear, love, affection, all sorts of different things, all just through that sort of sense of touch. And it's clear that the sense of touch is really rich, it's really important, but it's also clear that it's rather missing in one rather important aspect of our lives. So if we told you that the average adult spends 2 days a week in a world that doesn't have any touch at all, you could probably figure out that we're talking about our digital lives, our digital experiences. So the moment you log on to your phone, tablet, laptop, or you put on a VR headset or whatever it is, you basically leave your sense of touch at the digital doorstep, effectively. And I mean, I'd say with everything the sense of touch gives us in the physical, that's a big deal. But for the sight impaired, it's might as well be like stepping into a total void. So there's something in the order of 3 billion images shared every day. And if you don't have the means to experience them, that's 3 billion basically irrelevant things that are flying around. And so, what's the alternative? How do we explore different mediums? That comes down to digital touch. And by digital touch, we mean haptics. Haptic technologies are what let us recreate sense of touch via sort of digital means and explore digital touch sensations. And it's really important that these aren't assistive devices, nor is this actually an assistive project in any way, shape or form. It's a project that basically adds the sense of touch to digital creative expression, and it creates a more level playing field where sighted and non-sighted users can collaborate. Just like I would say that, I mean, assistive devices aren't really, very few assistive devices do anything other than help readdress the imbalance caused by humans designing the world in a rather viso-centric way. And so haptic devices really are just something akin to a keyboard or a mouse or a computer monitor or a pair of headphones that give you that extra information channel for touch. And it's pretty complicated because the sense of touch is really, really quite complicated. In sort of a simple way, it's made up of a combination of receptors in the skin that give you sort of texture and temperature and pressure, along with sensors in the muscles that tell you about forces and your sort of your broad position, your gross position, that kind of thing. That's all fused together. And we try to use digital technologies, various kinds. Some are force feedback devices with motors, other ones vibrate, some sort of stretch the skin or provide electrical impulses to make the muscles move and things. And they're designed in such a way to try and recreate the sense of touch in exactly the same way that a computer monitor tries to give you a virtual view of something that's computer generated. And it's really curious, or a lot of people find interesting, that haptic devices have been in use since the 50s. They were in use in telerobotics in the nuclear research industry, and that was a good 20 years before the first computer monitor showed up. But the result of that combination of technology being around for a really long time, and the sense of touch being really complicated itself anyway, where we are now is we've got a huge array of different physical interfaces for touch without any kind of standardization, any sort of real overlap even between how they work or how they interface, that kind of thing. And that's created a bit of a sort of a no one size fits all situation, and also a bit of a nightmare in terms of sort of development. And so if you want to just flip on to the next slide, Lisa. That's what we're trying to address with the technology platforms that we create at Generate Robotics. So one of the platforms is a software platform called Toya, and it's specifically haptic middleware. And the overarching goal really is to basically place the center of creation and creative sort of authority into the hands of designers rather than programmers. So at the moment, programmers primarily work with haptic devices and create sort of haptic experiences. And what we're doing is we're creating design tools that make that as simple as the graphics and visual design process, so that designers can create touchable experiences. Designers can add the sense of touch to their interactive or digital experiences, and they can do it in a way which is easy to deploy, maintain, use, and everything else. And we're using Toya to create what Lisa's about to describe, which is effectively this online virtual makerspace where people can use the sense of touch to interact with different kinds of sort of deformable and malleable media and sort of express themselves through that medium. I think that's the end of my little slidey piece.
Thank you, Ali. Okay, so adding on to the story that Ali's just started, I wanted to start just before the project to really kind of offer you a background behind inclusivity and behind the community of sight impairment. Helen Keller is a lady that was living and working around the 19th century. And as you can see from the screen, the quote is, "Alone we can do so little, together we can do so much." This lady was an American author, and she was a great activist for ability needs support and bringing ability needs communities together to work together to solve each other's problems. Way ahead of her time, way before inclusive design was a tiny dot in the universe. She was working and living and sharing, and a great advocate for working together and bringing our skills together no matter what your ability. And this is really the kind of grounding for our project here. So one of our main ideas as craftsmen designers is to connect the brain, the mind, and the hand. There's lots of quotes and literature around how designer makers, craft makers, artists, whether it be hobbyist or professional, and how they mediate their thinking through their hand. Richard Sennett talks about the intelligent hand. Immanuel Kant talks about the hand being a window to the mind. It's really a connection between a learning sensory input and the material that we're working with. So this is very much kind of craft in a craft studio, and you're working with sensory experiences all the time, and your mind is connecting with what you're feeling and creating forms, stitching, crafting, modeling, and all of this time we're creating our own unique version of whatever we're forming and whatever craft we're making. And there's no more community that are linked with this to exploit touch in this way than the non-sighted community. So I talked about community and talked about inclusion. What does inclusion really mean? Inclusion, universal design and co-design are all kind of leaves off the same tree. Inclusion is really a sense that you're working with an individual that you're answering the problems for from the very start. It doesn't have to be an ability needs, it is in our case, but it doesn't have to be. The inclusive part is that you're including your customer or your end user, within the proposal, from ideation to development and right through to delivery. Where universal design is much more of an extreme version of that, in that a universal design is good for everybody, but it's actually been designed for an extreme version of society. So, for example, OXO are a universal design company. They design things that are for people with motor skill impairments, arthritis, with the concept that if anybody with arthritis can grab and hold some of their kitchen tools or some of their household tools, then it's good for the populace, the mass market. Co-design is a little bit different in that we respect our co-design participants as having some part in the design process. So they will input not only their thoughts, but elements and suggestions to change the design, to add to the design, to develop the design, and certainly to involved in the iteration. The co-design participants are an absolute asset and a boon to any research team, because we believe they are the experts on their condition or their reasoning behind the issues. And in a little bit in the same vein as Helen Keller, together we are stronger. So we're a community. We become a community with our participants. We share our thoughts and our process. We hold the expertise in design and process and design and problem solving and questioning, problem raising. And our participants share their experience of living with their condition. We come together as creative, like-minded. Quite a lot of our participants are in fact designers, professional or hobbyist, or craft makers, designer makers. They work with their hands to enrich their and value of their time and share that with other people. We hope we are empowering. We certainly try to be. They are empowering to us. Our participants are extremely empowering to us, and they certainly strengthen our creative process. Every time we meet, I always come up with new ideas and get new thoughts from our users, and they inspire me every day. So as an inclusive designer working within assistive design for a number of years, I've worked with various assistive tools. As Ali said, this particular project is not on that vein. It certainly could be called co-design, it certainly could be called universal design, but we are literally leveling the playing field for our users to bridge the technology gap that they're currently struggling with. Various other people have worked with assistive technologies in different ways, and I just wanted to share that with you. Particularly the smart cane. The smart cane was developed as a way to help users get around and increase their mobility in towns and cities by increasing their ability to find and source objects in their way. The reason that I've shown this, particularly on this slide, is because the smart cane is obviously held by a user, and it's remote and controlled as the user tapped it on the ground. But that's gaining a source of touch, not only from the hand, but via an object. This sensory cue is very different, but certainly one that our non-sighted and sight-impaired participants are very familiar with. They are able to detect their sensitivities to touch as such, but they're able to detect and understand cues that are sent to them via objects, as well as actual holding the object itself or holding the desk. So their afferent for touch sensitivities goes in some ways far beyond the reach of an able-bodied or a sighted individual. Certainly something that Bacarita has come across in his time, the 1969 study. He viewed a couple of tests where a user was wearing some glasses and they were related, but they could see as a picture through their skin. The actual substitute of tactile feeling and perceptions is something that's been worked on since Bacarita's study. And again, it's something that touch on the skin can deliver so much, not only for orientation, but for an understanding of what the user is seeing, in inverted commas, and coming back to that seeing hand and feeling through senses in new ways. So altogether, really, within this project, to sum up, we're designing with people rather than designing for people. We believe that creativity is there involved, creative practice is there involved in everybody, and everybody can bring something to the table. So with that, and it's an introduction to our project in a more salient form. For sight impairment creative community, we discovered that it was really difficult to to bridge the technology gap and create simulation other than Adobe and AutoCAD beyond that, and give them something that they can sense more intuitively. Obviously, Adobe and AutoCAD are very visual-centric, as is the barrier for non-sighted. We're in a visio-centric world, which I think one of our participants put quite succinctly. The world is becoming very, very visual, and in a document, we're seeing different pictures, we're seeing different drawings, videos, we're seeing very different types of visual effects. Because of a lot of the technology, the blind person cannot communicate, cannot give to the world. And I think this is at the very rooted heart of where we're coming from, is enabling our community of blind participants to be able to give back, to give the world something that is from their creativity and from them as a person. It has their creative agency all over it. And we're facilitating that. So we're designing for people, created by people. So these are our people, these are our tribe. Certainly part of our research team. I have been working with participants, 2 female, 2 male. We have 2 blind, severely visually impaired people classed as clinically blind. We have 2 sight impaired people who are, sight impairment really touches on the area of sight acuity that is far beyond wearing glasses. So it's somebody that's no longer able to gain a better sight through wearing glasses. Interestingly, the education of our participants is 2 have had a specialist education, what one might call SEN, so special education needs. So they've been trained from the moment that they were in education on how to work and live as a blind person. And we've had 2 participants that have been involved in mainstream education with assistances. So we have a range of creative experience. We have arts that they would consider themselves as experts, and we certainly would. They also consider themselves as novice to some arts, and haptics, we've had non-specifically experience with haptics. So this is an image from one of our participants. She is completely blind and has been so for a number of years. It's interesting, if you look at the screen, you can see that she's created a floral element with some leaves. And the creativity is there in the mark making and the depth it creates. Interesting when you consider that this person has no sight. So she's created that in a sight occlusion, in the darkness, in effect. And she's felt and she's experienced. Our participants have told us this before, that they go to a place or they feel something and it gives them an experience, an understanding, and it builds up as a map of a picture in their mind. They find it difficult to work with digital graphics, although some of our sight impaired users have overcome this in various ways, often by screen readers or by braille control, digital keypads. It's a shame because they enjoy working with textured medium, and the textured medium could come out so well with using graphics. They often use sound as well as touch, and that's just as important, although they would say that sound is secondary in some cases to touch. It depends what the experience is. A few of our sight impaired, and to some extent some of the severely sight impaired participants, have said that they need a particular daylight to enhance more levels of sight. This is a kind of eccentric sight where if you've got direct sunlight, you can see little windows popping in your vision, which gives you little abstract elements of sight. It can be quite confusing at times, and it can certainly be quite tiring. Quite a few of our users have worked with assistive technologies, but they say if it doesn't really come intuitive or it saves them time, then they abandon it. And I'm afraid to say this is the story that quite a few ability needs people have reported over the years. So before I play this next film, I'd like all of you to close your eyes and draw a shape. I'd like you to draw a shape, which is a simple shape. It could be a square, a triangle, something that's familiar to you. Just close your eyes for a few moments and draw a series of shapes. I'll just give you a few moments to do that. What I'd like you to think about when you're doing this is about closing the loop on the shape. Try and make it a whole shape, so you take the line back to where you started. I'd like to also think that you can work with your shapes and maybe join them together if you feel creative enough, or if you feel confident enough. Really have a think about what shapes you're representing, and perhaps why you're representing those shapes. By about now, you should be all experiencing that it's not as easy as you would expect. Okay, let me stop you there. If you all got your own shapes, I won't be asking for them later. It's not a test. I just now like to play this film, which is one of our users drawing a tree. If you notice, he's using a home cue. In this sense, he's using a pencil sharpener, and he's using it to return to, so he has a platform and a base. He's creating the tree lines of the trunk. If you notice, he's moving up from the tree, and often if you see any child drawing, they often do the tree leaves first. He's realigning his cue points. And now he's drawing the leaves. Okay, so that individual, I will add, has never seen a tree. All of you in internet land just now have presumably all seen some shapes. And I'm sure, like me, whenever I've done this kind of activity before, you struggled just now to draw a shape that's completely closed the loop on the shape, or drawn a shape that you would actually recognize given it again. This is the wonder that is working with people with various abilities, and how they overcome their ability needs to push their creativity further, and it astonishes me every single day. Another astonishing aspect to our users is their innovation. This particular user has been working with how to enlarge drawings. He has a sight impairment, to overcome his sight impairment and using CAD. So he wanted to be able to create a magnifying glass of sorts, which are incredibly expensive. And so we overcome this by using a tablet and drawing, and he was able to make the tablet size larger and smaller to scale. This was his own construction, and part of the co-design and participatory inclusive design process is valuing where your users are at and what they're using to extend their practice. So I spoke earlier about the discover, the define, develop and deliver, the Diamond D. We have worked with Diamond D before as designers. We worked specifically with this project because we wanted to be able to elaborate further for our own needs, and certainly for the overall research project, where our users would be involved, and as co-designers, what they would glean from it and how we would glean information from them. And part of that is the discover, define central process. In this area, we wanted to create a clarity and understanding of what we were discovering from our users, what we were evolving and developing, and building those relationships with our participants so that they could trust us and understand what we're doing, but also we could understand their values and their needs and their own interventions for their abilities. So we weren't going to go over ground that they've covered before and just gone, look, you can't go further with this. I can't do that bit. I can't get involved in that bit. I've tried it before, it didn't work for me. I've tried this adjustment. So we were looking at what they could offer, building those relationships, and keeping everybody else in the loop as we went over our first diamond. This is what we discovered from ascertaining our participants' level in our deep dive workshops. Just a couple of aspects there. We asked them, what type of creative activity do you like to do? And quite a lot came from participants that they like to experience things. They want to be able to go into streets, they want to feel objects, they want to draw those objects. They want to be able to do 3D drawing and use 3D printing, just like everybody else. And it was interesting, just like Helen Keller, this particular respondent, this participant, wanted to be able to do something for people in wheelchairs. So they were able to access a greater range of places. And she wanted to use her designability for people with disabilities, just like herself. We also asked, what is your personal creative wish list? Now, this is not only looking at the project, but also asking in general when you're designing, what do you struggle with? And this particular participant stated that she would love to try 3D work. The new tool that we were promising and devising and working with her on should resemble a pencil. It should allow me to draw. It should allow me to choose colours. It should use AI to tell me the shapes and objects, and the drawing and the colours that she was using, because obviously they don't have an overview of that visual. They have to remind themselves constantly through touch of what they're actually drawing, what they're planning to draw should come to mind, and that bigger picture should be building all of the time. And if it doesn't, it creates a gap between hand and mind, and then it becomes quite confusing for these artists. So we asked in our deep dive statement, what's important to you? What's really do you want to get from this study? What would you like to get back? And the most important aspect of the study, all of the designer makers that we spoke to said, was to maintain creative practice, was to keep their creative practice going and further it and push it and tackle that technology gap. We're all familiar with what we've just gone through in the pandemic of the last couple of years, and certainly for the blind community, for the sight-impaired community, that's no different. In fact, it's almost more concerning as they were locked down and feeling disenfranchised in that lockdown, because all they do is touch, and all the time we've been told not to touch. So they were looking for art and craft involvement that would enrich their level of well-being. They wanted to work within their own medium, and they wanted to be able to work with paint and 3D. They had personal wish lists, that they wanted to be able to go beyond their own boundaries of working with digital technology from the past. They wanted to be able to share a screen and to work with others. They wanted to combine like-minded individuals on the same connection, the same space, just like working in a studio. And the smallest thing they wanted was assistive technology. Quite a few of our participants, and certainly with working with ability needs over the years, I've known participants and respondents share their thoughts on assistive technology. And it's certainly not a negative response from them, but they feel that assistive technology sometimes doesn't allow them to overcome a normalcy, an understanding that they are fitting into society. They almost feel that assistive technology singles them out as individuals, and not in a positive way. It kind of singles out their needs rather than them as a person. And we need to remind ourselves that there's so much more to the person than their ability. So we asked them, and we drew up profiles. We worked with them to kind of hang a profile list that explained a lot more in detail about that individual. We discovered that they also like drawing for pleasure, just like anybody else, apart from the commissions they sometimes get. They just like drawing or modelling. They rely heavily upon online drawing tools when they can, because some of them don't have that ability, and scaling up on a screen is too abstract for them to use. They like feeling textures. Wherever they're working, they'll feel textures. Texture is tantamount important when they're drawing. and feeling the indents of a pencil on a paper, or feeling the touch of clay or cloth or metal, as if they're working with jewelry. They need to feel these elements to tell them more about the image they're building up in their mind of what they're actually making. So this is the what, why, how of our development testing. We came to the development testing hub to doing the deep dive study, and we were testing users' perceptions working with 3D shapes. We wanted to understand, for our needs more than the participants' needs, what they were able to perceive on screen, and what would the screen 3D shapes offered the participants, and how they were able to touch them and understand them. Were they able to understand them as 3D shapes, or did they somehow see them distorted when they were touching them? Were their touching limiting them, or was it giving them a better picture? The aim was to produce a haptic design concept proof that would allow people with the sight limitations we've discussed to access modeling and 3D manipulation tools within a studio environment, to facilitate them to hold that creative agency that is so important to get out the other side of the project. We worked, of course, with Haptic, which was from a company called Haply Robotics. For anyone out there in internet land that understands Haptic, Haply is a 3 degrees of freedom, which means it can work in 3 degrees of access on the screen, on 3 different levels of plane approach and connection. And we worked, of course, with Ali and Toya software for the interface. We created a pre-trial testing, which was the shape discovery, and we were working with touching spheres and tubes and cones and cubes. And then we went on to a main phase testing, which was much more about tracing and tracking around a sculptural head, which looks a bit like a piece of stone sculpture. The participants were asked to touch all of the shapes on screen with the haptic device, and to palpate and to trace and contour the shapes to understand the shapes on screen until it built up to an effective picture in their mind. We needed to understand what the participants could really gain from the 3D sculptures to let us go to this next level, which would then be doing something more creative and building with the structures to make more of an arts forum. Ali, I don't know if you want to come in on here.
Only if you want something specific. I mean, so we're using the Haply Inverse 3 there, which is really literally right hot off the press, as it were, one of the newest devices we have access to. And it's just really nice because it gives us a nice big workspace, which users, especially the sight impaired, really appreciate, and they've sort of fed that back to us. But it means we can let them explore anything we can create on screen, really. And so, as Lisa said, in this sort of first instance, we're exploring static shapes, but we're also, I don't know if we've got video of this bit as well, but we're also able to sort of manipulate dynamic shapes and shape cloth and then freeze it in place. And then you can sort of see and understand. Because I think the one thing that's often hard to understand about these different kinds of devices is that this device specifically, like many others, is a force device. So the human sort of haptic sense gathers information about sort of position and shape through all sorts of different kinds of interactive modalities. And these devices give us really interesting force profiles. But when you're interacting through a single point, it's very hard to understand global shape. And that means you're presenting a world based on forces. And forces are what we consider to be sort of secondary qualities in psychophysics. Your primary qualities are things like sort of just, let's say, the geometry of something. You can see the geometry of something and you can feel it. So it sort of goes across multiple senses. Whereas something like mass or force is unique to the sense of touch. And so we're sort of creating quite a unique environment here because we're creating a force world. Something, a pure experience based on force. So you understand a shape based on the force direction you push, or you leave behind a forced trail, effectively, if you're pushing and pulling on this cloth and shaping it, what you effectively leave behind is a memory of the forces that you applied to a shape. And then when we freeze it in place, you trace over it and things. You don't necessarily totally understand the shape, because, as I say, you're interacting through a single point, but you understand how forces vary across the geometry in the plane. And it's a pretty sort of unique medium, basically, and something that you almost need to experience both haptically and visually as sort of someone seeing what someone's created, effectively.
Thank you. Okay, so this is a first look on the interface and one of our users working with the interface. As I said before, what we're really trying to do is to heighten the mental pictures, to build on their individual's understanding of what they're feeling, and then activating that to what they're perceiving. And we want to lower the mental model because, as you can imagine, when you've only got one point of touch, quite a lot of perceptions are being received and then being translated, and that can create quite a heavy mental load if the users aren't used to it. So it's something certainly to move forward and get used to. This is I'm just going to play some film from the testing. I think you will enjoy and perhaps find out more from seeing the film.
Are you sharing the whole screen, Lisa, or are you sharing the?
Yeah, I was trying to. And it's,
or just is it just the PowerPoint, or is it the screen?
It's the screen. It's just going a little bit slow. Okay, doesn't want to play. And I hope turn on to the next slide. Okay, so we'll try and get the next one. Okay. So some of our findings, some perceptions are shared within that. What I'll do is actually get these dropped into the PowerPoint so you guys can see those online. Our participants gave us some feedback when they were working through their trials. Some of our participants couldn't actually detect some of the parts of the 3D shapes, and they kept kind of a haptic black spot, so they were feeling and they weren't getting any resistance or, as Ali described, force back. They were tracking and tracing the haptic device well. They were understanding quite clearly what some of the shape edges. One of our participants said he liked kind of feeling the top of the cube, and then he kind of dropped down the sides and felt the sides and realized it was a cube rather than a square. It was all particularly relevant to how they built up their mental picture, which is all really good feedback. We wanted to be able to look at modeling and movement for latter stage testers and for the next level. We were looking at intuitive movements and unintuitive movements. And some of our users worked with movements that worked away from the body. So they kind of pushed the stylus and the hand away from the body, more towards the screen. This was really interesting because they said that moving the other way, moving from the screen back to their body, wasn't quite as intuitive. And some of that could come from their training of how to move around and be mobile in an environment, and how they perceive areas and solids and surfaces and movement within a space with obstacles. So we're taking all of that as evidence of their understanding and their natural intuition, and we're moving forward with that in our next phase testing. All of this is gold dust to researchers. So as Ali offered before, we're working with haptics, but haptics is a science, a human science, and we are within the British Science Week. Haptics is a study of the human science and exploration. Two female keynotes, Lederman and Colazzi in 1987 came up with manual exploration perceptions, or EPs for short. And this is a tactile understanding of how humans explore objects. So they worked with various ones that you see on the screen. They did contouring, they supported a global aesthetic. Ali talks about passive, which is when you kind of sit your hand still, but still understand the surface or the feel or the weight or the force of something or the resistance to your hand, when it's static. Added to this is proprioception, is understanding where your hand is in space. It's certainly something that the haptic deals with, and certainly a perception that we don't think about too much. But if anyone's come home late and you've moved your hand to turn on the light switch in your house and in the darkness, then that's a proprioception movement, and switching on the light switch is a memory, and it will come back to you immediately of how to do this. Or if you tie an apron behind your back, your hands behind your back, tying a bow behind your back, then that's also proprioception. You understand the movement even though you can't see it. And it's something that our participants do, the non-sighted participants that we work with do really well, and they understand and they explore the levels of their own limitations. Interestingly, on the screen, when we were looking at the films from the test, quite a few of these movements and exploration perceptions were being carried out by our participant, one. She worked with the shapes for quite some time, and she was palpating them, she was contouring them, she was working statically with them, but exploring and motioning around, moving, rolling around the shape to understand and build that shape in her mind, which was really interesting.
So when you're ready, Lisa, just by the magic of technical wizardry, it looks like you can just request the videos and someone will play them for you.
Okay,
so,
can I have the user evaluation, please?
You have to give up your screen, possibly. I'm not quite sure.
Thank
there
you.
we go.
Thank you. The elves and the pixies backstage. Fabulous. Thank you. Okay, thank you. Can we get so I can share again? Okay, so as we talked about, now you've seen the film, you can understand some of the levels of perception and understanding. We got some positive feedback. We still have some interesting points to look at. Points that, if I'm honest, we wouldn't have considered coming from a sighted perception. So again, you know, it's enlightening as we work through this. Just to really discuss an overview, and we've looked at today the use of co-design and inclusive design, including the user's input and valuing it. We've spoken about our Makeactive-UK project, and we're building tools together, developing future technologies with participants, working with participants as experts. We're offering them an alternative sensory input rather than primary sight input, where rotational sense, dual sense abilities, working with sight, touch and sound. We're offering the users creative agency, and we're working with creative communities in a post-pandemic. So we're looking at building digital creative communities to support a virtual design access for all. To support alternative access to remote learning in the Open Universities remit. So we're joining together, and just like Keller stated, together we are stronger. Ali, do you want to talk about
Lisa?
Do you want to talk about the next level?
Well, I think the thing I'm really excited about is that what we do next as part of this project is we create a collaborative experience. And so we're doing that by taking advantage of something that's fairly unique to the UK, actually, which is the academic network infrastructure. So there's a super fast network that connects all the UK universities together called Janet. And we can use it to create interactive collaborative environments which are haptically enabled in a way that you can't do over traditional sort of wide area networks. So we did some trials last year that were really good between universities, and so we're going to run it again as part of this project, but to create a collaborative creative environment, which could be multiple creative agents, or it could be a sighted assistant working with a non-sighted creator, or it could be the process of a sighted person exploring and understanding what the non-sighted person is creating. So whatever it is, it's two or more people in the same environment, online, digitally, and physically interacting. So when someone applies a force to something, then someone else who's touching that thing instantaneously experiences that force. So you might be pushing and pulling on the same medium or cloth, or you might be sort of tracing behind someone, or you may just sort of grab hold of someone and pull them over to an area of interest and sort of say, oh, this is the nose, or this is the cheek, or here I've created some interesting shapes and things. Do you want to explore that? And so that's where we're headed, basically, and we believe that that's sort of the basis for really a lot of different kinds of STEAM education and creative processes. whether it's just about sort of creating online physics lessons, or whether it's about sort of collaboratively sort of designing engineering processes, or just mucking about and exploring and interchanging and exchanging ideas and everything else. So there's a lot of opportunity there, and it comes down to the fact that people can physically interact with each other in a way that's just doesn't happen in a visual way. People are very playful. In fact, when we did the tests last year, we had a Zoom window inside the VR environment as well. But people very quickly just stopped looking at it and looking at each other, and just started, focused on the task they were doing, a collaborative task where they had to sort of, one person picked up the needle, another person had to thread it and work around, and quickly they sort of kind of develop their own little ways to interact, like doing little fist bumps and things to each other and all sorts of stuff. And these natural modes of interaction just evolve quite intuitively. And so we're really excited to see where that goes.
Yeah, certainly. If you can imagine our non-sighted participants being able to sit down and use computer-aided digital design collaboratively as a community, working and connecting with others and peer critiquing others' work by touch in the same way as any other student or any other creative maker working in a community, and creating that virtual studio space would be so important to people who are vulnerable and can't really come out into the big wide world, just as sighted people are able to do, and in the same way connect with those kind of studio practices. So really we'd like you to consider the metaverse. If you don't know what it is, then I would offer that it would be great to Google it. I've yet to read the same definition twice, so that's how new it is. And the understanding is that it could create a new sense of working paradigm, not only for the creative community, but for society in general. Thank you very much for listening in today. I will open the floor for questions if colleagues Louise and Katrina would like to.
At least I've popped a couple of questions in the chat, but one to get you two started. Are there comparable technologies out there? Does anything else like this exist?
Not exactly like this, no. They were working with considerably off-the-shelf haptic technology, but there is nothing like the interface that we're working with, and certainly not in the way that we are working in the kind of freestyle, touch-based collaborative format. No, not to our knowledge. The other question is, why is it important to use haptics for remote communities? I think really because we're humans. As humans, we certainly the creative communities do like to touch. They like to touch different fabrics, different textures. Some designer friends of mine getting absolutely inspired just by touch. So I would say generally for the creative community, then touch is a valued perception and sense
Okay, so we're going to try to get you guys back up and running. I have never been kicked out of Zoom before. Going on. Up and answer that. So,
Yes, I can answer it. Yeah.
yeah. So Sam, go ahead and just go. And then if you let me know in the chat that we're live, I will apologize and get us back on track. Apologies, everybody, for that. We have never been kicked out of Zoom before, so there's a first for everything. And in 2022, we are still figuring out Zoom events. So my sincere apologies. We've got Lisa, and Alistair is just coming back on now to answer your questions. So I will hand it back over to them, but a sincere apology from us. Right, so I'm not sure what question we were on, but we did have a really good one about potential uses for students. So are there any plans to use this as a way for all students, not necessarily creative, to interact with visual materials?
Yes, indeed. Certainly at a distance learning, remote learning online university such as the OU, we have been working with colleagues at the Open University, and certainly we're looking at what provision we could provide, what we could offer our applied discipline students, so students working in STEM, science, technology, engineering, mathematics, and also sciences. And design, engineering in the main, and certainly creatively adding that touch back to their remote distance learning experience, and aiding those touch skills going forward. Because obviously remote learning, that touch and get involved in materials is not as present as we would like.
So I'm not sure, have we talked about long-term change that you want to achieve through devices like this?
Do you want to speak to that, Mary?
Well, our long-term change really is to make the digital experience just much more physical, realistically. So we'd certainly like to obviously level the playing field for anyone with particular sensory impairments or motor impairments. Doesn't have to be visual, often just motor and movement difficulties make haptic devices a much better way to interact with digital media. But more than that, yeah, I think we're right on the cusp of sort of a technology maturity, where these technologies are both sufficiently capable to provide really meaningful and useful experiences, and computing power and technology infrastructure, communications, it's all sort of kind of meeting at a point where we can do really interesting and useful things. So like Lisa's sort of speaking to, you know, creating more general sort of digital touch experiences for education, for distance learning. There's loads of opportunities across training generally, be it surgical and medical. Lots of really interesting things opening up in robotics and sort of disciplines like that. And the creative arts have really embraced these technologies a lot. You know, music, design, CAD. There's a lot of opportunity, a lot of interest that's definitely coming out of this move, and we want to make sure that touch is really represented. So the big companies, the big unicorns, Facebook and Meta and Google, everyone else, they're betting big on a future where we are not just on our phones, we're immersed in a virtual environment. They're putting billions and billions into content for these new online worlds. And yeah, the long-term change we want to see is that isn't a visual and auditory experience. That's a tangible, a real, as one of the participants said, a visceral experience, whereby you can physically interact and communicate. And yeah, just to flip back to one of the previous questions, I think it was just as we cut off, sort of why enable haptics for remote interaction, and it's really actually much more fundamental than just sort of trying to make something a bit better. There's a lot of psychological research that suggests mental health is really adversely affected by long-term lack of touch and physical interaction. And so if you are housebound for any reason, could be because you live remotely, could be because you have a physical disability, it could be because you're isolating, it could be for any number of reasons. But being able to allow people to physically interact with colleagues, with collaborators, with loved ones, that's a sort of a long-term goal that I think we'd really like to see realized, and hopefully not the long term.
Yeah, I think it's that point, because we're at the kind of point at the moment where we're actually future thinking, but we're already working in the future of what would have been inconceivable a year or 2 years ago. We're working with haptics on a level that actually embeds it, rather than just the seduction of using a haptic tool. We're actually putting it to a need in a wider multimodal and multimedia experience. So touch becomes part of what we do, and we immerse ourselves in that touch, in that new environment, in the virtual world. So we start to believe that virtual world, and we become part of it. And for people with ability needs and people at home, this is a great leveler. Looking at touch and virtual immersion leaves people to be people, and they don't have to be whoever they are believed to be. Their impairments or their ability needs or their mental health needs are unimportant. They're a person, and they're involved in a virtual place where everybody is at the same place and level. That leveling ability is all part of the inclusive design process, and we're really, that going forward is what haptics and this kind of environment can give.
That's great. We are out of time despite getting picked out. Again, very sorry for that. So if either of you have anything you just want to say to wrap things up and goodbye, yeah, please do so.
Just really thanks from my point of view for joining us today, and 3 words: watch this space.
All right, thank you everyone.